So now we'd just like to get the machine to tell us which of these building footprints actually overlapped an area that got burned, to help identify what are the structures that were likely lost. And so to do that, we basically want to be able to look under every footprint, right? And so if we zoom in, we're gonna wait for it to draw, but I just kind of zoomed in and there are the building footprints. So let's look under this one. It's a little bit bigger. It's on Empire Grade, um, and which uh, is great a great highway in, in Santa Cruz. And so there's a building footprint. There's some of them, and basically what we want to do is grab them based on we want to identify what the burn severity was underneath the footprint, right? So we're basically going to try to say, all right, what's the highest burn category that is under each footprint, and let's attach that burn severity, the maximum burn severity, let's attach as an attribute or as a property of each building footprint. Is that fair? That's what we're trying to do. So we're going to go back over to the here and we're going to select buildings in burned areas. So the first step is going to be what I just said, and then so the first step is going to be to just try to grab the value from the image that's underneath the um, feature, and then we'll select a subset of features based on the ones that were in these higher burn classes. Is that okay? That's my thinking here. So I'm going to paste in this that we got from here. And then the first step, the burn severity buildings versus the burn buildings. So the first thing, the difference between these two is that the first step is trying to say what's the maximum value in our classified burn severity layer um, under each footprint. So to do that, we're going to say we want to start with the burn severity classes um, layer. And I'm actually going to grab this whole thing, the burn severity classes with the ocean mask, because I actually think there's a building that might be out there in the water, and I don't want to deal with that. I want to hide that one. So I'm going to use that image, and I'm going to say, please reduce regions, right? We're going to go, it's happening to be right here, but this is in the image tray. And underneath that, the last time we used a method from here in image, it was for the n, the normalized difference, or the normalized difference. And we're just now going to use reduced regions, which remember applies a reducer of the area of each feature in a collection. And so I'm going to go ahead and grab that list, copy it, and bring it in to here. Is that fair? And so our collection, and I'm just going to do it kind of this way, where I put these in a dictionary, and then I can kind of keep track of what each one does. So our collection here is the buildings, right? Because that the collection has to do with the features or the feature collection that we are using as, you can either think of them as like cookie cutters or we're using them as individual spoons. And we just want to, for some reason, I still like cookie cutter as because we're cutting stuff out of the dough. Anyway, that's that. For the reducer, I think it makes sense that we want to grab like how bad did it get associated with this building. So we want to get the highest burn class, right? The highest burn severity class. So that to me is the max. And if we wanted to look it up, we could go to EE Reducer, and we're going to go after EE Reducer Max as our dot max, and with the belly like that. For scale, I'm going to have the scale be set at the Sentinel scale. And so these pixels, I think, are 10 meters. If you look at these little squares, I think they represent 10 meters by 10 meters. Sentinel is higher resolution than Landsat, which is kind of nice. Um, okay, so for projection, the CRS, and we know that this kind of winds up, um, uh, it does matter, and we found that out in the other, in one of the earlier independent problems. So to get around that, I'm just going to say use whatever projection of our dough. Is that fair? So the idea is that under image, there is a method called projection um, right here. And so it's going to return the default projection of the image. So I can just say for the CRS, just use whatever projection that this thing is in. And then for these other variables, I'm just going to ignore them because we don't need to do the transform if we list the CRS and tile scale. I'm not going to worry about right now either. Is that fair? If this part confuses you, you can just test it by saying print this and so print CRS is just a tag, so you know what this thing is over here, and um, it's mad about something because yeah, we haven't done that yet. So let me comment that out and then hit run. But over here under CRS, there should be a projection. If we look at the projection, wait for it. There it is, EPSG 4326, and I'm just gonna feed it that for now. And does that work? And so that got us this, which if I say print um, the if I say print this thing right here, I'm going to copy it and paste it into here. I was looking for a handy label, but it's just going to be the thing that comes out after we say CRS. So we now should have this, and the question is, do we kick out an image? We started with an image. What do we get out? And we get a feature collection out, right? And it's working really hard because there were kind of a lot of, we just asked it to do this over 15,262 features. And it's kind that it's actually doing that, but I'm going to give it a break and say, actually, I'm kidding. You don't need to print that whole thing out. Just give me the first one so that I can make sure that what we did here works. And it's going to work hard. And I can say, I'm just kidding. You don't need to tell me that anymore either. And hit it, run again. And I don't need it to tell me this anymore. I'm not going to hit run again, but just when you see it spin like that, you can tell that it's slowing things down. So if you don't need the information anymore, it's good to just comment it out. And so cool. Now we have the capture date for the image, which is for the footprint. So that's helpful because it's telling us that this thing was there before the fire, and we could probably that's something that we can talk about. And then max is what we um, just tagged it, right? Because it is the max means that it was in this unburned area. That's fair, 0, 1, 2. And so now let's kind of comment that out and say, well, if we want the burn buildings and we have a feature collection, I think we just need the burn severity buildings. I'm sorry if these names aren't really that intuitive or helpful for you, but we just need to filter these and say EE filter dot anything greater than, and if we say max, then let's kind of think this through and say, well, if this is 0 and that's 1 and that's 2 and that's low severity 3, let's just say anything greater than 3 may have been kind of damaged if it was moderate to moderate to high severity. So if we just change that to 3, um, and then change this to print and say run, we're going to get an estimate of the number of buildings that got burned in the fire. And it's going to be, I think, quite a bit lower than what the CAL FIRE reported. And we can talk about the different reasons, but this is a kind of a conservative maybe estimate. 651 um, buildings that got torched, which I think is about half of what the CAL FIRE reported. But again, I'm not sure if by structures CAL FIRE was including, some of the tiny sheds that we saw that may not have been, you know, the sheds that I showed in the slides today that may not have actually been picked up by Microsoft, um, especially if they're under tree canopy. Anyway, so there's reasons why the numbers might be a little bit different, but it's a first guess. So now let's kind of get these to draw on the map, but I'm going to do this in a different